derivatives and some things that come out of it. Let's take the derivative of f prime. The result is a function called the second derivative, and we note it by f line and call it f double prime. Okay, in Leibniz notation, we use this, the second derivative of y with respect to x. Okay. So find the second derivative of y with respect to x if y is equal to x to the sixth. Well, if y is equal to the x to the sixth and I want the second derivative, I start by taking the first derivative. The second derivative is the derivative of the first derivative. And I could keep on going like this. Why don't you take the third derivative for me? And after 3, our notation is this. We put that in little brackets. It doesn't mean y to the fourth. It means the fourth derivative. Which is why this Leibniz notation is maybe a little less confusing. So y triple prime, what do you got? Y, the fourth derivative. Okay, we could keep going. What's the fifth derivative? What's the sixth derivative? What's the seventh derivative? And what's the eighth derivative? 0, 0. And ever after that, it's going to be 0. Okay, so just keep on taking the derivative of a function. If it's a polynomial function, it gets easier and easier to take the derivative. If it's a radical function, it just gets harder and harder to take the derivative. So we want to find just the second derivative. So let's start off by writing our function in exponential notation. 5x squared plus x to the 1/2. Then what is the first derivative? Go ahead and take it. Okay, so there's the first derivative, 10x plus 1/2 x to the minus 1/2. Then take the second derivative, f double prime at x. That would be 10 plus, taking the derivative of 1/2 x to the minus 1/2, well, I'm going to leave the constant out in front, and take the derivative of x to the minus 1/2. That would be negative 1/2 x, subtract 1 from the exponent, would make that negative 3/2. So looks like I'm getting, simplifying this, 10 negative times negative, positive times negative, negative 1/4 x to the negative 3/2, and no negative exponents. I've got 10 subtract 1/4 x to the 3/2. Just by the way, if you're seeing this in radical notation in your answer key, it would look like this, 4x root x. So I'll give you a minute to think about that. You should be able to see where that's coming from. All right, then let's do it with a chain rule. So here's f at x. What's f prime at x? Well, it's 10 times all of this to the 9th times the derivative of the inside function, which would be 2x, and it's negative. And let's simplify this. Just bring this up to the front. I've got negative 20x bracket 2 minus x squared all to the 9th. Okay, there's the first derivative. So you see the second derivative starts getting more complicated because this first derivative gave us a product. It's like this is our first function and this is our second function. So product rule for taking this derivative, then we've got the first function, negative 20x, times the derivative of the second. And that's going to require a chain rule. So we've got 9 times 2 minus x squared to the 8th times the derivative of the inside function, negative 2x. And it's a product rule, don't forget. You still got to keep going. Plus the derivative of the first function, negative 20, times the second, 2 minus x squared, all to the 9th. Okay, we could work at simplifying this, but look at what we're asked to find. F double prime at 1 means just put x equals 1 in to that equation, and I think it's probably just as easy if I don't bother simplifying first. Negative 20 times 1 gives me negative 20 times 9. 2 minus 1 squared to the power of 8. Negative 2 times 1, and I'm 1 to the 8th, of course, is just 1, plus negative 20 times, if x is 1, 1 squared is 1, 2 minus 1, 1 to the 9th, still 1. Okay, so I've got negative times negative, positive 40 times 9, 360, subtract 20 equals 340.